Hello students, welcome to a new lecture of chemical bonding. In the last class, we were discussing about the molecular orbital energy diagram MOED of molecules till nitrogen. From now, we will see the molecules after nitrogen, which is oxygen molecule and fluorine molecule, right? So, till nitrogen molecule, the diagram which we have seen was unsymmetrical in nature. Therefore, in the same diagram, I have added one electron after making a molecule to the next level, right? But from oxygen, it is different. So, I will draw the diagram again. And you know that the bottom level 1s2, 2s2 is same for all the molecules, right? Which molecules we are going to do first is oxygen molecule, in which this is oxygen atom having what is the configuration of oxygen? 1s2, 2s2 and 2p4. Same, let us draw the orbitals also. 1, 2, 3, 4, 1, 2, right? Same way, another oxygen atom having the same electrons. 1, 2, 3, 4, 2p4, 2s2 and 1s2. So, this is another oxygen atom in which 1s2, 2s2, 2p4. Now, both of them combines in linear combination of atomic orbitals method. Let us move this a little bit towards left. Diagram should look very neat and all the necessary information should be provided in the diagram itself. Okay. So, this is 2p4. You need 2px, 2py, 2pz, no need to write, it becomes crowded. Now, 1 orbital, 2 orbital, two molecular orbitals, out of which this is bonding 1s2, this is anti-bonding sigma star 1s2. Total how many electrons? 1, 2, 3, 4. 1, 2, 3, 4. Same way for this. This is bonding sigma 2s2, this is anti-bonding sigma star 2s2, right? Total how many electrons? 4 electrons, right? Next going to the 2p atomic orbitals. Total how many bonding? Total how many? 1, 2, 3, 1, 2, 3. So, total should be 6. Out of that, this is the symmetrical diagram. On this side of the half, pi then sigma, here also pi then sigma. Earlier it was not the case, sigma then pi was there, so the diagram became unsymmetrical, but here it is symmetrical. Now let us count the number of electrons. 1, 2, 3, 4 plus 4, 8. 1, 2, 3, 4, 5, 6. Next is 7 and 8. What is this orbital name? Sigma 2pz, 2 electrons. This is pi 2px, pi 2py, right? This is anti-bonding, pi star 2px, pi star 2py, and this is sigma star 2pz, right? Total 8 electrons are present, right? This is the molecular orbital energy diagram of oxygen molecule in the center. So, right now let us write the electronic configuration of oxygen molecule. Starting from the first, who is the first in energy? Least in energy is sigma 1s2, then followed by sigma star 1s2, then followed by sigma 2s2, then followed by sigma star 2s2, then followed by sigma 2pz2, then followed by pi 2px2 and pi 2py2, both of them having the same electrons. After that, pi star 2px having one electron, pi star 2py having one electron. This is the electronic configuration of oxygen molecule. Now by seeing the electronic configuration or by seeing the diagram also, let us calculate its bond order. Bond order of oxygen molecule. What is the formula? Total number of bonding minus anti-bonding divided by 2. Bonding 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6. Total 4 by 2, which is 2. So in oxygen molecule, how many bonds are present in between two oxygen atom? Is 2. So oxygen molecule has 2 bonds, right? And now what is the nature of the compound? Can you find any molecular orbital? Molecular orbital, not atomic, means center. Any molecular orbital has unpaired electrons in it or not? You have to check. No, it is not unpaired, it is paired. How about these? Is it unpaired or paired? Unpaired electron. How many unpaired electrons? There are 2 unpaired electrons in oxygen molecule. Therefore, oxygen molecule is paramagnetic in nature, right? Bond order is 2, that means 2 bonds are present, and nature is paramagnetic in nature because it has 2 unpaired electrons, right? This is for oxygen molecule. This is only the required information for oxygen molecule. In the exam, if it comes for 4 marks, all the things which you are finding on the board should be there in your paper, then only your marks will be, you will score full marks. Now let us apply the same diagram by adding 1 electron each for the next molecule. What is the next molecule? Fluorine molecule. So shall I erase all the calculations of fluorine molecule? Yes. So do I need to draw the complete diagram again? No need. In this diagram only I will make changes by adding 1 electron for fluorine atom and another electron for another fluorine atom. So instead of oxygen atom, what is the next atom? Fluorine atom. Instead of oxygen atom, what is the next atom? Fluorine atom, right? What is the electronic configuration of fluorine atom? 1s2, 2s2, 2p5. What is the electronic configuration of fluorine atom? 1s2, 2s2, 2p5, right? So now 1 electron I have added extra which comes here, 1 electron I have added extra which comes here, right? So now after adding here 5 electrons, here 5 electrons, total 10 electrons should be there in this area, but there are 1, 2, 3, 4, 5, 6, 7 and 8. Where should be the 9th electron? Here, because pairing should be done, then only go to higher energy. 10th electron should come here, right? So this is fluorine molecule in which a total of how many electrons? 2, 2, 4 plus 5, 9 and 9, 18 electrons are accommodated in this region, in which let us write the electronic configuration of fluorine again starting from the bottom. Why we are writing again? for each and every molecule is, you will become perfect in writing the electronic configuration starting from the bottom. Once your diagram is correct, because I told you to practice the diagram 10 times for each molecule, at least the last 3 molecules, nitrogen, oxygen, fluorine, very thoroughly you have to practice. If you write the diagram correctly, all the information is there in the diagram itself. By looking at the diagram, you can easily write electronic configuration and calculate the bond order. Let us write the electronic configuration of fluorine atom molecule. Sigma 1s2, sigma star 1s2, next is sigma 2s2, sigma star 2s2, sigma 2pz 2, pi 2px 2, pi 2py 2, then again pi star 2px, here there are 2 electrons, here also there are 2 electrons now. Pi star 2py 2. This is the electronic configuration of fluorine molecule. By looking at the electronic configuration, let us calculate its bond order. What is the formula of bond order? Number of bonding electrons minus number of anti-bonding electrons divided by 2. We are calculating the number of bonding electrons right from the beginning, right? You can also calculate the number of bonding and anti-bonding electrons in the last shell itself. If you calculate the number of bonding electrons and anti-bonding electrons in the last shell, means this area only, even then your bond order will come correctly. But till now we are following this order only. So for fluorine also let us do in this way only, starting from the beginning. Bonding electrons 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. How many bonding electrons? There are 10. Anti-bonding 1, 2, 3, 4, 5, 6, 7, 8. 8 divided by 2. That means 2 by 2, 1 bond only. In fluorine molecule, there are only 1 bond between 2 fluorine atoms, right? Now, any unpaired electrons are present or not in the molecular orbitals? No unpaired electrons. Therefore, the molecule is diamagnetic in nature. This is a fluorine molecule in which unpaired electrons are absent. Therefore, the molecule is diamagnetic in nature. Now we have finished the molecular orbital theory completely, starting from the first molecule like hydrogen till fluorine, right? In the exam you need to prepare for nitrogen, oxygen and fluorine. Shall I rub the board? Now everything is clear, right? Now we will move on to the last topic of chemical bonding, which is hydrogen bonding. And that is also very important for your short answer questions in your exam. Hydrogen bonding is such a type of bond which is not shown by a normal line. It is shown by a dotted line, right? Let us see how it goes. Suppose I will take water molecules. If I have a glass of water, in that glass of water there will be so many water molecules present, right? Side by side. But I am taking only 2 water molecules. For our understanding, there will be many, right? So this is one water molecule, another water molecule. In the first water molecule, there is oxygen atom in the center, which is electronegative in nature, and hydrogen atoms electronegativity is way more lesser than oxygen, right? if you compare the electronegativity of oxygen and hydrogen, there is a huge difference. Oxygen is having high electronegativity, hydrogen is having less electronegativity. This oxygen also shows the same difference and this oxygen also shows the same difference, right? As they are surrounding each other, they are side by side to each other or not? Like this, there will be many water molecules surrounding this central water, right? So, because of electronegative nature of this oxygen atom, what it does is, it will try to attract the hydrogen atom of the other water molecule, not its own, not its own, but its own is already bonded by a line, nothing will happen to that. But hydrogen atom of the other water molecule is also nearby only. So, what it does, the electrostatic forces of attraction will develop between oxygen of one molecule and hydrogen of the other molecule. That electrostatic attraction is developing because they are very close. And that electrostatic attraction, which I have shown in the form of dotted line, is only hydrogen bond, right? Normal bond is shown in the form of line in a single molecule, here as well as here. But electrostatic forces of interaction is in between oxygen of one water molecule and hydrogen of the other molecule, right? That electrostatic attraction itself is called as hydrogen bond. Now, let me define what is hydrogen bonding. And it is not as strong as this normal bond. It is very weak compared to normal bond, which is strong. This is weak. That's why dotted lines, right? So, the definition is the weak electrostatic forces of interaction between oxygen of one molecule, not always oxygen, more electronegative atom of one molecule and hydrogen of the other molecule. Hydrogen is must, right? More electronegative atom can be oxygen, can be fluorine, can be chlorine, can be sulfur, can be nitrogen also. All of them are more electronegative. In the periodic table, all the elements present on right side are more electronegative only. So, in place of oxygen, if nitrogen is also there, means the same attraction is developed, right? So, the definition is the weak electrostatic forces of interaction between more electronegative atom of one molecule and hydrogen of the other molecule is called as hydrogen bonding, and it is weak, and because of that hydrogen gets a positive charge, partial positive charge, and oxygen gets a partial negative charge. Partial, not completely, it is partial, right? This is hydrogen bonding. Hydrogen bonding is again of two types, which is intermolecular hydrogen bonding if I am showing a bond between oxygen and hydrogen by a line, it is not a hydrogen bond, it is a normal bond. If I am showing a dotted line, then only it is hydrogen bond. Remember always. Okay, and another type of hydrogen bonding is intramolecular hydrogen bonding. Coming to intermolecular hydrogen bonding, inter means in between two molecules. In between two molecules, if hydrogen bonding is taking place, it is called as intermolecular hydrogen bonding. Example I have taken is water molecule. Not always water molecule, you can also write the example of HF, right? How? Let me show. This is HF molecule, this is another HF molecule. Fluorine is electronegative in nature or not? Fluorine of one molecule and hydrogen of another molecule develops electrostatic forces of interaction, and this is hydrogen bonding, right? And you can also see that in ethanol. Oxygen of one molecule and hydrogen of the other molecule. This is also intermolecular hydrogen bonding. To show the hydrogen bond, I have to take minimum of 2 molecules, right? Therefore, it is called as in between 2 molecules, nothing but intermolecular hydrogen bonding, right? In these molecules, more electronegative atom of one molecule I have taken, and hydrogen of the second molecule I have taken. Same way, more electronegative atom of first molecule, hydrogen of the second molecule I have taken, right? But in intramolecular hydrogen bonding, example, if a molecule is large, if a molecule is large, what is the name of this molecule? Orthonitrophenol is the name of the molecule. Is it small or large in size? It is large in size. If a molecule is large in size such that more electronegative atom present at one end and hydrogen atom present on the other end, right? On this side hydrogen atom is present, on this side more electronegative atom is present. This more electronegative atom from the other side develops a force of attraction with hydrogen atom present on the other side because it is large in size. There is no attraction in between because they are already bonded by a normal bond. But more electronegative atom like oxygen on the other side, hydrogen on this side develops electrostatic forces of attraction, which is nothing but hydrogen bonding. Therefore, the bonding is taking place, or the hydrogen bonding is taking place inside a single molecule only. Therefore, it is called as intramolecular hydrogen bonding. The example is orthonitrophenol. Hydrogen bonding. What is hydrogen bonding? What are the types of hydrogen bonding is a very important question for your 4 marks, and you have to practice it very thoroughly. Here I end the chemical bonding chapter, and from the next class we will see the next chapter. Okay, thank you.